I'm collecting cave millipedes here. Here's one. Which are blind and pale and have relatively long legs and long antennae, and those are characteristics that you often find in cave animals. We're here in a tropical cave in Malaysia, in Borneo, and as you can see, it's dark here. The temperature is high, the humidity is high. There's very little food. The food that is in the cave is brought in by bat guano and the occasional dead leaf or dead piece of wood that makes its way into the cave. So we see that the organisms that live here, millipedes, but also beetles and isopods, woodlice, springtails, all these tiny insects and other invertebrates, that they have adapted to these conditions. This is a very extreme environment, and they have adapted in very extreme ways. Often you see that they have lost their wings if they're insects, that they have lost their eyes, that they have lost their pigment, that they have a very long digestive system to make the best out of the little nutrients that there are in the cave. And from DNA you can tell that sometimes this cave evolution has taken place very rapidly. In just a few 100,000 years you can get from a regular outside insect to a very extreme and adapted cave insect. And that's what makes these tropical caves so fascinating to study rapid evolution. So until recently, the habitat outside of this cave was primary rainforest, tropical rainforest, and that's where the ancestors lived of the organisms that are now living inside the cave, that are adapted to cave life. But in the meantime, a completely man-made habitat has appeared here over the last few decades of rows and rows of identical introduced African palms, oil palms, and you could imagine that organisms are going to be forced to adapt to that man-made habitat, just like they've been forced to adapt to the cave habitat.